I'll make a video of these too, so if you want to look at them later. So there's your first one, solve for x. A little bit of a reminder of what our goals are for solving a log equation. Sort of our steps that we've used. Our goal with a log equation is to get that x out of the inside of that log. The way that we can do that is by using our definition of a logarithm and taking something that is in log form, using its definition and changing it to exponential form. The way that we do that is if we have a single logarithm. So our first step is always to see if we can write as a single logarithm. Because if we can write this, which right now has two logarithms, as one logarithm, then we're going to be able to do that key step, which is step 2, and change it to exponential form. Because once you change it to exponential form, you're getting the x out of the inside of that logarithm. And that's what our goal is. Because then it will be in a form that you know how to solve, and you can use your algebraic skills that you know to solve for x. The last thing that we always did with a logarithmic equation is we always had to check the roots, because if you plug a root back into an equation and you take the log of a negative number, that is not possible. So it's a possibility that one of your roots does not work because you can't take the log of a negative number. Oh yeah, no problem. No, we can't do that. No. And the 3 on the right doesn't have a log. You could do log 3 of 27 if you wanted, but you don't have to. Okay, you're in a good spot here. How do you solve that kind of equation though? You're trying to put in numbers to make it tiny, but you can only do this if it's equal to 0. This is a quadratic equation. You know how to solve quadratic equations. Yeah. Okay, but what's 3 to the power 3? Yeah, and what did you subtract? There you go. Those little mistakes, Ethan. Those ones catch. Oh, I've been recording for the last however long without So step 1, we want to write this as a single log. We have our log laws up on the board over there. It says when we add 2 logs, adding 2 logs is the same as multiplying inside the log. So I've got log 3 1 minus x plus log 3x plus 11. That's adding 2 logs with the same base. The log law says you can combine those as a single log. So now we have completed step 1. Step 2, which is the most important step, is also the step that most people forget, because it's a weird kind of step because you're using a definition. The definition of a logarithm says the base is 3, the exponent is 3, And the answer is what's inside. And now we have succeeded in getting rid of the logarithm because we've used the definition. The exponential part is just 3 to the power 3, which is 27. We can multiply this out. So we'll get x plus 11 minus x squared minus 11x. And it's a quadratic equation. How do we solve quadratic equations? With quadratic formula, but whatever, or factoring, whatever way we need to do, the first thing we do is make one side equal to 0. So I'm going to move everything to the right-hand side. I'll get a positive x squared. I have negative 10. It is, but if I'm going to move it to the left, right, I'm going to move everything to the left-hand side of my equation. So I'm going to move the 11 over, but I have 27, so this will end up with plus 16. Is this factorable? Yes, it is. It's going to be x plus 8 and x plus 2. So we get our two answers as negative 8 and negative 2. So if we put numbers beside what we've done here, this was step 1. This was step 2 where we changed to exponential form. This is the important one because that gets the x out of the logarithm and into a form that we can solve. All of this is step 3, which is old mathematics for you guys. That's grade 11 math. That's stuff that you've done before, solving quadratic equations. So really that key step, step 2, once you've done that, you take it out of the grade 12 realm and put it back into stuff that you've done before. And then once we get our final answer, we have to check those answers. Are they both possible? Are they both not possible? How do we do that? If you would leave it like this, this would say you've assumed that you've checked them and they're both right. If one of them is wrong or both of them are wrong, you have to show that you X them out. Now, the reason I picked this example, or the reason I made this example, was we got two negative answers. And you can't take the log of a negative number. So most students see a negative number, they put an X right through them right away because they're negative. And every example we did up till now, by chance, the negative answers all didn't work, the positive answers worked. But I chose this example in particular because I wanted to show you, you can't just judge them by how they look, you have to plug them back into the original equation. So let's scroll back up to here. Let's think about negative 2 first. If I plug in negative 2 into my first logarithm, I get a positive 3 in there. That's okay. If I plug in a negative 2 into here, I get a positive 9. That's okay. So I can actually say that even though it's a negative number, that one works. And with a negative 8, if I go back up, if I plug in negative 8 into the first one, I get positive 9. That's okay. If I plug in negative 8 here, I get a positive 3. That's also okay. So even though both of our answers were negative, both of those answers are possible. So it's a good example to see. So what I've tried to do in these 4 review examples that I've picked for this morning, one, I want you to review the steps because in this unit, all of logarithms, everything we practiced from 5.1 to 5.6 was all leading to the questions in 5.7. 5.7 is the most important section of this unit. Solving for x inside of a logarithm and solving for x inside an exponential function. And so knowing how to do both of those are going to be a big part of your test when we do our test. So here's our second example. Again, solve for x. We have log 4 x squared minus 2x minus a half equals log 4 of x. Again, I'll give you 5 minutes. So our first decision here, if we want to combine these as a single logarithm, we need to put our logs on the same side. So this is the first place that I saw some different answers. I would prefer to put the log base 4 of x on the left side and the 1/2 on the right side, because that makes this a positive number. But I saw some people bring other things to the other side. It'll still work out the same. Just if you're working with positives, there are less things you have to remember, and you end up making less mistakes. So now, what is our log law for subtracting? If you're subtracting logs with the same base, you can combine them together by dividing. So we have succeeded in doing step 1, which was combining things as a single log. Notice this one took a little bit longer to do that just because our logs weren't on the same side. So we had to move things around to get our logs on the same side in order to apply our log laws to put them together. Now that we've got it as a single logarithm, we can use the definition and change to exponential form. So the base is 4, the exponent is a half, and the answer is x squared minus 2x over x. So this is our step 2, changing it to exponential form. Now that we've changed it to exponential form, the logs are gone. This is an equation. This is a rational equation. You've solved rational equations before. What do we do in this situation? And this, too, is where we had some differing types of solutions. So I'm going to do the solution where we get rid of the fraction by multiplying both sides by x. Remember that 4 to the half is the same as the square root of 4. So the square root of 4 is 2. And if I were to multiply both sides by x to get rid of this fraction, I'm going to get 2x equals x squared minus 2x. It's a quadratic equation. We can subtract 2x on both sides to make one side equal to 0. Factor this. And we get two solutions, x equals 0 and x equals 4. So all of this was step 3, solving for x. The last thing we need to do is check our answers by plugging them back into our original equation. And the reason I chose this example is I wanted you to get an example where when you plug something in, for example, when I plug in 0, can you see in this first one that this would be 0? And we talked about not being able to take a log of a negative number, but if we think about what does the graph of a log graph look like? Well, it has this shape, and it has an asymptote here at x equals 0. That graph shows that you can't take the log of a negative number because there's nothing in the negatives. But the asymptote also tells you that you can't take log of 0. So by plugging in 0, we get log of 0. That means that this is an extraneous root. It's not possible. But when you plug in 4 into the original equation, this becomes 8, this becomes 4. Both of those are positive numbers, and so 4 is a solution. Yes?
Will 0 always be a non-commensurate value? Because I factored at 2, so
Right.
that would be x equals 0.
Right. So no, 0 won't always be a non-permissible value. So solving this way is better by factoring because it could be that it's a possibility. However, in this case, because there were some of you that took this step, right, and factored here, this is also a correct solution. Okay? Because at this point, if 0 was an answer, dividing by 0 is still a non-permissible value, so it would get canceled out that way too. So had you done it this way, you would have just got x equals 4 to check, and it would have solved just fine. So that's sort of a second solution. Some of you simplified early, some of you multiplied out and solved and simplified at the end, but both of them work equally. Example 3 is very similar to example 2, except this time I am going to put an x minus 2 inside that last set of brackets. How does that change our answer? Oh, hey, let's see. This one, again, because it's so similar to the last one, the first step where you subtract to get your logs on the same side of the equation, I'll move the half over to the other side. Again, we're working on our first step here to combine things as a single logarithm. Subtracting logs just like last time. We can divide, and now we've combined it as a single logarithm. So now we can go to step 2 and change it to exponential form. Again, the basis for the exponent is a half, just like last time. The only thing different is our answer now is x squared minus 2x over x minus 2. And again, this is where I saw people take two different routes. So starting step 3 for solving, there's the route where you multiply both sides by x minus 2. To get rid of the rational equation. 4 to the 1/2 is 2, so on this side you're going to get 2x minus 4. On this side you're going to get x squared minus 2x. This is a quadratic equation, so if you set it equal to 0, you get x squared minus 4x plus 4. And that factors to x minus 2, x minus 2. So you get x equals 2 both ways. And this is all step 3 solving for x. To check your answers, you've got to plug those answers, which are the same answer, back into the original equation. Again, that's an important thing. You're always plugging right back into our original equation. And here, when we plug in 2, we get log of 0. That means that these can't be solutions. And when all of them cancel out, it's nice to write at the end that there is no solution. Now, some of you, instead, at this step, you factored the top. Oops. And had your x minus 2's cancel at that point. To get x equals 2, that is fine as well. So there are some different methods as you're working through the algebra, but they all work out. So solve for x. There we go. Again, I'll give you 5 minutes. Let's go over this one. Now, step 1 is combining things as a single logarithm. We have logarithms on both sides. when deciding where to move things, because I saw some people move the natural log of 2 over, I saw some people move the natural log of x plus 3 over. I personally like to move things over, so the number that I have by itself, in this case the 5, I like to keep it positive, because I know that that's going to be my exponent when I change to exponential form. And positive exponents are easier to work with, because then you don't have to work with your negative exponent law. But moving things to the other side is not wrong. It just might make things a little bit more tedious. So now I've got a natural log, subtract a natural log. Your log laws stay the same. If you're subtracting, these have the same base. That's the same as dividing. So now we have completed step 1, which was try to get things together as a single logarithm. Step 2 is changing to exponential form. So with the natural log, you have to know that even though the base isn't written, the base is e. The exponent would be 5, and the answer is x plus 3 over 2. And that equation is easier to work with than the negative equation. Quickly finish it up here. Multiply both sides by 2. Subtract 3. And there's our final answer, which looks weird, but it is the right answer.